I love math, math, math. Math can change the world. I love two-factor. I like the box method. Don't miss a Mr. Ing video. I love polynomials.
Hey guys, this is Mr. Ing. Let's go over the composition review worksheet. Question number 1, we have 2 portions here. To determine whether the following equation is true. So when something is true, that means both sides are the same. And then they would not be equals if they were different. Okay, let's do the left side. This just means f of g of x. Remember the key to the whole worksheet is you're going to work right to left, work right to left. And you might want to just put a star by something like right here, and then you're going to work this direction. So to rewrite this, that's just going to be f of g of x. That just means you need to find g of x first. Well, you're putting g into f. So I'm going to write out f. And that means for every time that you see the x values, you're going to fill it in with g, which is x squared minus 1. X squared minus 1. So now we have f of x squared minus 1, and then you're putting this one here for the x value plus 1. Well, we don't need the parentheses anymore. So you have x squared minus 1 plus 1, and then you have these right here. Okay, the end result for this problem is the square root of x, these 2's will cancel, and you're just left with x as my answer. Another way to prove that to you is this. The numerator and then the denominator just comes x to the first. Okay, let's work on this side. This one is saying that we're going to have the f of x value is going to go inside the g. So I'm going to write out g. And now what I'm saying is that every x value is now going to become the f of x value. And then the f of x value is square root of x plus 1. Now, this is the same thing. Maybe it helps to just put parentheses around it. Remember, this problem, you have something that looks like this. So this become a rational exponent, they call. So 2 divided by 2 is 1, or you're just left with the parentheses as your final answer. So you're just left with x plus 1 minus 1. And then you're saying that these are like terms, so you have equal to x. Well, are these the same? They are. So that means that they are true. They are equal. So that would be our answer. Okay, let's try question number 2. I'm going to start on the inside on the right. So g of 5, this is my x value. So g of 5 means I'm going to come over to this one and look for the 5. Well, the answer is 8. The 8 now becomes the input for the next one, which is f. So f of 8. Okay, so I don't have a value of f of 8. So this one's going to be undefined. We cannot find it. Okay, this one says g of 7. So I have g of 7 is 2. And then the 2 is the output, now becomes the input for f. Okay, so then I have that one, so the answer is 5. 5 is my answer. Okay, g of 3. G of 3 is 10, so now the 10 is what I need for the f value. So there is no 10 for the So this one's going to be undefined. Yeah, that's messy, but it says undefined. Okay, last one, g of 10. So I go to g, I find 10 as my x value, and then the output is 11. Now I'm going to find f of 11. So my answer is 10 is our answer. Okay, so now it's going to ask me for the domain, which is the inputs for the x values. So just go back to the original problem, 5, 7, 3, and 10. They like to write those in order, least to greatest. And then this one says the range or the outputs, the y value. So that's the number that we have. You're not going to write the word undefined, but we're going to have 5 and then 10. The undefined basically means that you put in a video game system and output is it doesn't work. So that's kind of what undefined is. All right, in question number 3, we're given two functions, function f and function g, which is in pink. In question number 3, again, the trick is to start on the, if you need to put like a little star, you're starting there. So it's telling me f of 1. Well, now I go up to f, yellow, and I'm looking for an x value that is 1. And there it is. So its output, the y value, xy, is 3. But that 3 now, because it's the input of g of 3. So now I go to the pink. I'm looking for 3, and then my answer is 10. So 10 is my answer. Let's try this one, f of 4. So taking apart might help you in the composition of functions. F of 4, I have 7. And so now I use 7 into g. G of 7. That one is here. So my output is 2 is my answer. Let's look at this one over here. It's telling me to start with f. Again, if you want, you can have a little star. So f of 2. I go up to yellow, look for x values that are 2. There it is. So my answer is 5. Remember, this is an ordered pair, 2, 5, but you kind of see right there. That 5 now becomes the input for g. So g of 5, that is pink, and I have 8. And the last one, f of 11. There it is. That's 10. So g of 10, that becomes 11. So my inputs are my x values. So we put in 1, 4, 2, and 11. 2, 4, 11. And the outputs or answers that we can pick from are what we had. So you can pick 2, 8, 10, and 11. Okay, question number 4, it tells us that f of x is x squared minus 5 and g of x is 3x squared plus 1. It's telling us to determine the following. If I notice, this circle is not filled in. If it was a closed circle, it would be what class? Multiplication. So I did see that mistake already. This is not f times g. That is not the case. Okay? So we created a handy dandy chart on the front of our 4.1 packet. And fog can be written as f of g of x. And we said that we need to start on the inside and go from right to left. So f of g of 2. That means I just need to figure out g of 2 first. So I'm going to use what color? Yellow or pink? Pink. I'm doing this, and you'll notice that my input is 2. So every x value is going to be 2. 3 times 2 squared plus 1. I'm going to follow the order of operations PEMDAS. So I'm going to do the exponents first. Remember back in August, the common mistake was to multiply, but that would be skipping and Aunt Sally is not happy. So we're going to do 2 squared, which is 4, and then 4 times 3 is 12. And you add those together, I get 13. G of 2 equals 13. Okay, so I just calculated this portion. So G of 2 is 13. Well, now if you think about what we're doing, we're now calculating F of 13. I get the 13 because the output is now the input of our second one. So now let's calculate F of 13. So I'm going to use now yellow because it has F. We don't want F's in class, but now we're using this F. So I have something squared minus 5. Well, the x value is 13. So 13 squared is 169. And if I subtract from 5, then I get 164. So the end result is this. Fog, F, oops, that was a 2. G of 2, whatever my answer was, we got here. Then I put into F, and then my answer is 164. And it's kind of weird, I'm going to double box it. Why? Because this was part of the word, part of the answer I needed, and that's my final answer. Okay, question number 5, it says let f of x equal square root of x plus 5. So we worked on using colors, that might help you. And g of x is 2x plus 8. The notation here says f of g, fog. It's not a closed circle, so you're not going to do multiplication. I should not see this times that. That would not work, okay? So let's write it out in fully. This is f of g of 6. You're working from the right to left. We're putting 6 into g first. What color is that, class? It's pink. G is pink. So I'm going to write out 2x plus 8. And I'm going to put a 6 in there. And then I get 12 plus 8. So my answer is what? Class, what's the answer? 20. Yes? Is that my final answer? No, that was just the answer for g of 6. Now, essentially what we're doing now is we're going to put in 20 for the function of f. So f of 20. So I go over here, got my yellow now. So putting in 20. And I'm putting in 20 for every x value in f. That's why I wrote 20 here. So I have now 20 plus 5 is 25, and the square root of 25 is 5. And I'm choosing to double box this, because this was the answer just for g of 6, but that's not the complete answer. I'm going to put it in to f, and then I finally get my final answer of 5. Go ahead and try B now.
Okay, let's go over number 5b. The first thing I'm going to do is write this in function notation. And this problem is asking us very specifically f of 95. So what I'm going to do first is I'm going to find f of 95. So f of 95 is equals to, I'm going to put in 95 plus 5. So that gives me 100. And the square root of 100 is 10. Okay, so that's what I'm going to be putting into this portion. So essentially now I have g of 10. So let's summarize. The output now becomes the input. Say that one time. The answer of the first part is what I need to put into the for the second part. So g of 10. Now I have 2 times 10 plus 8. So this will become 20 plus 8. So my answer is 28. 28 is my answer. Okay, let's go to the back side. Number 6. Let f of x equal 5x squared minus 5 and g of x equal 5x plus 5. Find each function of its domain. So I want you to notice that this is a closed circle, and that basically means multiplication. But if you see something like fog, this means f of g of x. You would put g into f. Okay, so I can do f of x times g of x. F of x is this. So every time I see f of x, I can write 5x squared minus 5. G of x, I can write 5x plus 5. So let's just put those into here. And you're going to do the same thing. You're going to first multiply, and then you're going to add. So let's multiply 25x to the third, 25x squared minus 25x minus 25. Okay, so let's get my answer now. 25x to the third plus 25x squared minus 25x minus 25. Okay, so if you graph each of these, 5x squared minus 5 has a y-intercept of minus 5. A value is positive, so it's going like this. So my domain is negative infinity to positive infinity. The blue one is linear, so positive 5, positive slope, 2 arrows, negative infinity to positive infinity. So basically in this problem, we can say our domain is, you can do it in 2 ways. You can say all real numbers. X can be all real numbers. You could do something super fancy. You could say in the set for X, basically you pick all the real numbers. Okay, the second way you can write this is an interval notation, which is saying pick the least restricted domain. The most restrictive because they're the same, so it doesn't really change anything. Okay, let's try B. Now this one is saying f, or f of x, divided by g of x. So f of x is 5x squared minus 5, and the g of x is equal to 5x plus 5. Okay, so a couple of notes here. Let's see if we can summarize these. If the denominator is a polynomial, like x to the something power, like 3, then basically we just need to do not equal to 0. Whoa, what happened there? Not equal to 0. Oh, I know what happened. Let's see. We're going to do not equal to 0. That's one condition, okay? The other condition is, let's just say you have a square root. You have a square root in the denominator. Okay, that one just says that the number has to be greater than 0. Greater than 0 is one of those conditions. So this one is not equal to 0, greater than 0, and then the last one, your condition is if you just have no fraction and you have a square root, like this. So the difference is this one has a fraction line, this one doesn't. You're going to do the same thing. You want that number to be greater than 0, whatever's on the inside. So denominator, I guess it's just these two right here. Okay. All right, so this one is the red condition because I have a fraction denominator, and we're going to set it not equal to 0. And treat it like an equal sign, just solve it. So I'll subtract 5, divide by 5. That's saying that x cannot equal 1, negative 1. So our domain is all values of x such that x cannot be -1, and then all real numbers after that. Or you can say something like -infinity to -1, but the parentheses means not include. And then we're going to unify that with -1 to infinity. Those should be parentheses. Okay, so let's summarize. Our answer is here in dark blue, with the domain of either of these two. Okay? Okay, number 7. Same thing. I noticed that it is a closed, so I'm going to do F times G. Do you see the difference? It's a closed circle, so I'm just multiplying those. 5x squared times the square root of x plus 20. Now, you're not going to distribute or do anything like that, so you're just going to leave it like that. Then I probably want to figure out the domains of these. Let's figure out. So let's do the blue. So 5x squared, you could just do something like this, right? -1, 0, and 1. Put in your values. -1 squared is 1. 1 times 5 is 5. 0 gives me 0, and then 1 squared is 1. 1 times 5 is 5. Okay? So you would get something like this. Therefore, my domain is -infinity to positive infinity. Okay, the orange one is square root of x plus 20. Okay, I'm going to be a little more strategic, and I'm going to put in -20. Because if I put in -20 up here, -20 plus 20 is 0, square root of 0 is 0. So that's, I do want the intercepts. You could do it the other way around. We can put in x value as 0. That gives me the square root of 20. The square root of 20, I don't have a calculator, so I'm just going to estimate square root of 25 and the square root of 16. So I know it's between 4 and 5. Let's just say 4.4, something like that, or square root of 20. So -20 is 0, maybe 4.5, and our graph's going to look like this. Okay, so this one, the domain is, I'm going to start at -20 and not include -20, and then I can go towards positive infinity. So this is the most restrictive domain, and that's the one we're going to use. So my answer is 5x squared times square root of x plus 20, and the domain values that I can pick, you can do -20 to infinity. And this one, you can pick -20 because it does work. So this would be my answer. Okay? Okay, let's go ahead and try this one over here. So I have f divided by g, or g of x. F of x is 5x squared, and g of x is the square root of x plus 20. Okay, we already know kind of the answer, but I can't pick -20, right? Because if I put -20, that would be 0. So let's go ahead and do that one. So that condition up there is the purple one. Let's do that in purple then. So this one, x plus 20 greater than 0. So x has to be greater than -20. So my domain for that is, let's do interval notation. You can say all values of x such that in this set that x has to be greater than -20. That's one way. Or you can do interval notation, just say, nope. I want numbers bigger than -20, so start at -20. This one you cannot include -20, and we're going to go towards positive infinity. So let's highlight our answer in blue, dark blue. So this would be my answer. Okay, last one, number 8. Determine the following graph belongs to the function. Determine the domain. So determine the domain and then answer it. So 2 things we got to do. Okay, so what is the domain? The domain, remember, refers to x values and inputs. And maybe here's a question you can ask. Is the roller coaster at these? So my question is it at negative numbers? Negative numbers. That's not hashtags to older people. And then let's say at 2. And then positive numbers. Positive numbers. So let's go through these. No, the graph is not at f of x here. So let's say orange. This is where the roller coaster is. Okay. How about at 0? No, it's not there. Okay, so let's pay attention at positive numbers. Yes, it's in the positive numbers, but particularly at 2, should we say that the graph will touch 2? So let's see if I can draw this line. Let's not do that. Let's do it in red. I'll do my best to draw over that line. Okay, the question is, does the orange touch the red? Well, if you zoom ahead, that's not possible. It's not going to touch. It's going to, we use the words in math. We say the word approach. I have a phrase, 4th period laughed. Don't touch my ass in tote. That red line is a vertical asymptote. And what that means is the graph will get very, very close, but will not touch. Okay, so let's go back. I'm not going to include 2. Don't include. That means you're not going to have a bracket. You're going to have a parentheses. Okay, it's not this one because we're not coming from negative numbers. And then we have B or C, and the correct answer is going to be B. The parentheses means you're going to start at 2, but not include 2. Not exactly $2. You can do $2 and 1 penny, $2.10. All the positive numbers, that works. Just want to point out something with interval notation just to help you. I hope this helps. You know, it looks like an order pair, but it's not. Everything on the left side, I used green, is the left side of the graph. Left side. And then everything on the right side, that represents what's happening over here on the right side of the graph. Okay, so left side of the interval, left side of the graph, right side of the interval, right side of the graph. That's why, although it says the graph is pointing up, those refer to the y or f of x. But this one's just saying on the x-axis, can you hit the graph? Okay? Hopefully that was helpful. See you guys there. Bye.